In this video we're gonna talk about surface integrals. Okay, surface integrals means when an integration is evaluated over a surface. Okay, so as you see that here is an curve. So this is taking as ds. Whenever we are integrate the ds taking projections or over a surface is known as surface integrals. Okay, so when the surface S projects onto the region xy plane and S be the representations and z equal to fxy, then the surface area will be the ds root over of this are area. Okay, the final is I will just coming to this one. So this is the area. Okay, ds equal to root over of fx square plus fy square plus 1 root over. Okay, dA. So whenever we're talking about these curves, let assume that this is a curve. This is surface where s be the surface and z equal to fxy. Okay, function of x and y. So let s be the surface and ds be the portion of its surface. Okay, for evaluating surface integral, we have to make projections on xy plane. So let this is a we have to take the area ds. Okay, we have to project each point. Okay, each point will map on this xy plane. Okay, so this is a portion. So each point of this portion will just project on x and y plane. After taking projections, we have to integrate so that we get our surface integral. Okay, so make sure that whenever given that we have to make the projections in xy plane. Okay, as you see that after that whenever taking in projections in xy plane, we have to uh, written as ds equal to whenever as you see the dA after projecting you have to written as order of dx dy or dy dx. Here see that at that dx dy or dy dx. Okay, so in questions it comes that whenever we have to take of paraboloid projections or cylinder or a cone, for that you have to move through a how it is happening. So we have to take an such type of such you have to know about such 3D diagrams as paraboloid and cone or cylinder. Okay, okay, this is your surface. Means here is your point s or a surface is x and the function f of x comma y. Okay, so whenever taking projecting from this portion to xy plane, means this is your xy plane and this is your space. Okay, so whenever project on xy plane and then there is an area which is you have to integrate through which the all the surfaces get covered with double integrations of ds. Okay, so whenever we have to making projections of this curve, projection of this curve as you, so whenever we have to project this curve, each point will be projecting on xy plane. After projecting the projections will be a circle in xy plane, but how it is get a circle as you see. Okay, so now through questions we can get more clear about how we evaluating this integral in a surface. Here we have to evaluate the integral where the surface is given z equal to 2 minus y. Okay, so as you we write as z equal to f of x comma y, and it is given that 2 minus y, and also here is written as the limit of x varies from 0 to 2 and y varies from also 0 to 2. Okay, so as we know that ds equal to fx square plus fy square plus 1 root over dA. Okay, so we have to find fx and fy. Fx means this is 0, fy means 2 minus y means minus 1. Okay, so our area should be fx square means 0 plus fy square minus 1 square means 1 plus 1. Okay, and after after that we get root 2 dA. Okay, So our area will be root 2 dA. Then here it is given that the limit x varies from 0 to 2 and y 0 to 2. Okay, so x 0 to 2 and y 0 to 2, xy ds, here it is given that it means root 2 dA, root 2 and dA, where it can project in xy plane or the surface. After we getting that, it is dy dx. Okay, so root 2 0 to 2 y square by 2 0 to 2 dx. Okay, a 0 x root 2 0 to 2 2 squared 4 by 2 means 2 minus 0 x dx. Then we have to go for 2 root 2 0 to 2 x dx. Then after computing x square by 2 0 to 2, it is also 2 root 2. Here 4 by 2, 2 means 2 means 4 by root 2 is your answer. As you see that this is the method of which is your z equal to function of xy. Okay, alternatively we will do alternatively, as we just change this in functions of f of x comma z, as you see here that z equal to 2 minus y is given. Okay, so we have to change just we have to I just alternatively, this is another method. Okay, y equal to 2 minus z means here we convert that in f of x comma z, function of x and z. So for ds, as we know that fx square plus fy square plus 1 dA. So here we have to integrate dy by dx equal to 0 means here fx equal to 0, and now we find about dy by dz. Okay, here I just written as just here it can change means here is fx square plus fz square plus 1 dA, because we have to compute through the integrals functions function of x comma z. Okay, so dy by dz means minus 1. Here also there is same things happen, 0 minus 1 square plus 1 dA means here also root 2 dA, the same thing just going over. Okay, when it is also given that x varies from 0 to 2 and y varies from 0 to 2 means we have to y varies from 0 to 2 means 2 minus z also varies from 0 to 2. Okay, so as I write 0 to 2 and xy dx dz, this is also same thing that we get from the integral, and the answer is 4 root 2. As we compute this integral, we get the answer. Okay, here it is given that this is your surface, we have to integrate over a g of xy, it is given that xy ds. Okay, and here is a limit given that x varies from 0 to 4 and y varies from 0 to 4. So for that as we know that we have to first find ds. Okay, fx square plus, this is our formula, fx square plus fy square plus fy square plus 1 dA. Okay, so you have to first find fx. Fx here it is minus 1. Okay, and fy is here also minus 1. Fx square means 1 1 plus 1. Okay, this is your root 3 dA, and simply you have to now compute these ones. So here it is given that x varies from 0 to 4, here also 0 to 4 x y and root 3 dy dx. Okay, taking root 3 outside and x square by 2 0 to 4, and after that dx. Okay, sorry, dy This is also 0 to 4 root 3, then 0 to 4, here is your y dy, then 4 square means 16 by 2 means 8y. Okay, 8 taking outside y dy. Okay, so then 0 to 4 root 3 8 y dy. So 8 root 3 y square by 2, 0 to 4 means 8 root 3, 4 square 16 by 2 means 8 minus 0 means 8 64 root 3 is your answer. Okay, it is just about here it is just you have already given that the surface we have to integrate over these functions. Okay, so these are the concepts, and in next video I will talking about taking about another concept of this double integrations. Okay.